The next thing we're going to do is create a graph. Graphing is very important in science and in math, but in science it is a way to visualize information. And if you've been online at all, you've seen a lot of graphs lately about COVID-19 and the numbers of people that are infected. It's just going up and up and up and up. When we graph, we take all this information and visually represent it. We take all of this data and visualize it. So really a graph is visualized data. That's really what it is. We're taking information, putting it into a picture so we can make sense of it. Okay, so let's look at, Bertus loves scientific method. So let's look up here. Here we go, right here. Pretend your experiment was with the wingspan of the planes and the distance the planes traveled. That was your experiment, let's say. We're going to say you had 3 different planes, which you did, but yours might not have been the same thing. It's okay, it shouldn't have been the same thing. Let's say I had a wingspan of 10 centimeters. I had one of 20 centimeters. I had one of 30 centimeters. All right, I threw them each 10 times. And then I took the average distance traveled. So I threw, let's say this one, I threw it 10 times, added up measured how far it went each time, added up all those numbers, and then divide by 10, because I did 10 trials to get the average. Okay, so the average, let's say the average was 5 meters. Then I took the plane that had the wingspan of 20 centimeters, threw that 10 times, measured how far it went each time, add them up, divide by 10. Let's say the average was 10 meters. Same thing for the next one, and it was 15 meters. So this is data right here, okay? Now we're going to put this into a graph. So what are the 2 things we're looking at? We're looking at wingspan and average distance. And in the other video, talked about the variables. I just want to review because a graph is going to show that relationship between the 2 variables. So we're going to graph these variables. Okay, the wingspan is the thing that I changed in this experiment. I changed the wingspan. Everything else was the same. I changed the wingspan. That's the variable that's independent of everything else. It's like the manipulated variable. It's the thing I manipulated. So sometimes it's just called a manipulated variable or independent variable, IV. Okay, so that is the IV. Independent variable. Think of it as like the cause. Now it's not always the cause though. This relationship between these 2 might not be cause and effect. But it might help you remember the difference between IV and dV. So I always think of it that way, even though I know that it might not be a cause and effect relationship. But this is similar to the cause. So wingspan. The effect then of this changing the wingspan could be the distance of travel, the average distance. So the dependent variable depends on the independent variable. That's why it's called the dependent. Okay, so this is the dV. Okay. Now, we talked about constants or controlled variables. We won't graph those, right? But the experiment should have a lot of controlled variables if it's a controlled experiment. You want everything to be kept the same except for the one thing you're changing. The only thing that really should have been different among those 3 planes is the wingspan. Let's talk wingspan. Here we have Brutus demonstrating flight. But this is where the idea of flight came from, right here. So he, right here, this is the origin, this is him right here. This dude right here is the original. In fact, he should get royalties for every flight. Brutus should get royalties for every time JetBlue Southwest takes off. Brutus should get some money from him. All right, because he is the original. Birds. This is where we get these ideas. They come from nature, the natural world. I'm going to graph these numbers. So when we make a graph, first we want to figure out what are we graphing. We're graphing the relationship between wingspan and average distance. Okay. The next thing, we want to figure out what type of graph. There are many types of graphs, and we're going to learn about that in the next episode, so stay tuned. The next episode, we'll have types of graphs. So when's you use? How do you know? How do you know to make a scatter plot or line graph or whatever? In this case, we're looking at wingspan. How do we know which graph to use? We have to look at the data. A couple types of data. We have continuous data. Continuous, it's like along a continuum. So, like infinity. We can start with 0, go to 0.1, 0.2, but there are numbers between these, right? So continuous is data. It has really an infinite number of possibilities. Discrete data is limited. So continuous data, infinite number of possibilities. Number. Continuous is finite. There's limits to it. So finite means there's limits. Infinite, unlimited. It's not finite, it's finite if it's limited. So finite, limited. Discrete data would be like categories of things. Like if you were to do a survey on different social media sites, you know, what teenagers spend most of their time on. And you have limited social media sites. There's not an infinite number, although there might be. Right now, there's a limited number. Hello? All right, so you got Snapchat, TikTok, Instagram, Twitter, Facebook, all those. But there's a limit to them. So those are just, this is not an infinite number of social media sites. Okay? So right now, that would be considered discrete data, or like they're categories of things. So if I asked you what's your favorite pet, I did a survey and I wanted to graph the results. There's not an infinite number of pets. All right? So you have dog, cat, the usual, bird, somebody's got a horse. But it's not an infinite number of possibilities. I mean, if you really think about it. Okay, so these numbers are infinite, okay? So this is continuous data, so that's the first thing. So when you're working with continuous data, there's a couple of graphs that should come to mind. Scatter plots and line graphs. Okay? Scatter plots are used to really show patterns. Woo! Show patterns in data. Whereas linear or line graphs want to show a progression or something happening over time. All right, so we're going to actually, I want to see a pattern. I'm going to make this a scatter plot. I'm going to show you how to set up the graph, and then we're going to graph it. So I might have to enlarge this, but for now, I want you to look at the data here too as we're doing this. So the first thing I'm going to do is title the graph. That's the thing that most people forget. So we gotta title it, we gotta give it a title. In this case, there's many different possibilities, but we do want to include these two variables. So I could say the effect of blank on blank, or the relationship between blank, blank, or blank versus blank. Okay, so I'm just going to say the effect noun, of the independent variable on the dependent variable. It's gonna be the title of my graph.
All right.
I'm gonna fill in wingspan, distance traveled. So I'm gonna go back, effect of wingspan, plane's wingspan. And we know this is paper plane, so I'm just gonna wingspan on just average distance, or displacement is more accurate. Distance. Okay, so there we have our title. Number one, the first thing in a graph is the title. And it's weird because that's usually the thing most people forget. Everybody wants to just put the points in. They just want to start putting points in, and then they never remember to put the title in. So do the title first, because that's what tells us what the graph is about. The next thing you're going to do then, title is number one in a graph. Two, you're going to label the axes. Axis means one, axes two, or more than one. So that's going to be the X and Y. Now remember, we do a graph. The x-axis is horizontal and the y is vertical. Okay? So the x is where the x is where the independent variable is going to go. IV goes here and dv goes there. Okay, so I'm going to have down here, I'm going to have wingspan. I'm going to write it out. So we have to label the axes. Wingspan, and over here, the average distance with the units included. Okay, so that's important. Label with the units. And then we're going to graph them and see what we get.